Good morning, everyone. Thank you for joining us in this webinar on string handling and structured text. It's roughly about 18 minutes or so, and if you have any questions, you can put them in at any point and we'll get to them at the end.
Hello and welcome to today's webinar. Today we will be looking at string handling and structured text. Let's look at our agenda for today. We will start by reviewing what we mean by string handling. We will then look at the native structured text string functions that are built into CScape IEC programming. We will discuss some of the user-defined function blocks that you can access by contacting our tech support and can be used in your application when using strings in structured text. There will be demonstrations throughout, and we will finish with a Q&A session. First, we will define string handling. String handling is the manipulation of string type variables. String variables are based on ASCII encoding, where each character in a string is typically encoded as a byte value. This means each character has a decimal value between 0 and 127. This byte value represents a specific character, which may or may not be printable. CScape standard IEC editor handles strings as short integer arrays. This is an array of characters where each character is represented by a short integer or byte. Strings are terminated at the end with a null character, which is the ASCII 0 or decimal 0. Here we have an ASCII character table, which is an important tool for string handling. This table shows the ASCII values from 0 to 127. We can see that these are a mixture of characters that are printable, such as numbers and letters, and ones that are not printable, such as carriage returns, start of text characters, and delete keys. Let's look at some useful applications of strings in industrial automation. These include barcodes, reading and writing RFID tags, reading magnetic base cards, serial printing applications for receipt printing, and satellite communications. Now we will discuss some of the basic string handling functions that are built into the standard IEC editor in CScape. We will begin by looking at the string length array, which can be used to calculate string length. Here we can see the syntax for this array. When we are using this function, we will have a source string in the form of a short integer array. This will be the input to the function. The name of the function is string_length_a for string length array. The output of this function will then be the length of our string as an unsigned integer value. This function could be used to determine the length of a barcode as a string that we scanned in from a barcode reader. Next, we will look at how we can compare strings, such as comparing two different strings to see if they are equal and match character for character. To do this, we can use the compareString function, which compares a string against a variable string. If we look at this function's syntax, we can see that it is written in the form of an assignment statement, where we have a Boolean variable called match, meaning it will be set to either 1 or 0. We have two inputs for this function, which are both short integer variable arrays. These variables consist of a string of characters. If they match, then this function will return a 1 for the output. In this example, we are assigning this 1 to the variable match. If we instead want to compare a string to a fixed string, we would use a slightly different string compare function, called string compare constant. Similar to before, the first input variable is a character array. However, this time, our second input is a fixed string. In the example shown, this is just ABCDE in between single quotes. This function would be useful if we were reading in a barcode and we wanted to see if the value we read in exactly matches a specific fixed string. Next, we will look at some of the string handling user-defined function blocks we have created that you can use in standard IEC for your application. Before we do this, we will look at the syntax we will need to use to call a user-defined function block in structured text. Here we have the syntax for a UDFB called mid. In between the round brackets following this, we have four input variables separated by commas. These are en for enable, in_array, len, and position. This user-defined function block has two outputs. It has an output called ERR for error, and it has a second output, which is an array string, which is a string type output. In line 2 and 3 of our example syntax, we can see we are retrieving the outputs of the UDFB using assignment statements. So we have a variable called error, which we are assigning the ERR output of the mid UDFB to. On the next line, we have our variable output array, which is mapped to the output array of the mid function block. Now let's look at an example of how we would actually code this. Here we have some code from a structured text routine that is actually calling a UDFB, which in this case is the mid UDFB. When we are actually calling a UDFB from structured text, we call an instance of the UDFB. So if the UDFB we want to call is mid, we would need to create an instance of the mid UDFB. Here we have called this mid_FB. Then in our program variable listing, this mid_FB that we have created is set and typed as mid, because that is the name of the UDFB we are calling an instance of. We also have 4 inputs within round brackets, which are assigned to that function block call. These 4 variable names listed here in our actual code do not match exactly the names of the inputs from our syntax. It is important to note that we cannot give the UDFB instance inputs and outputs the same names as the UDFB inputs and outputs. We also have our assignment statements starting in the second line, where we have the error variable we have created. This is tied to the ERR output of the function block. Our last assignment statement is within a loop. This is needed for UDFBs that have a character-based array or a string array as an output, so that we can retrieve those characters one at a time. So in the example shown, we are executing 32 of those assignment statements as we retrieve each character one at a time to create our output string. Now we will look at the specific UDFBs we have created, which are available to use in your string handling application with standard IEC. The first few UDFBs we will look at are useful when parsing incoming strings. For example, if we have a barcode we are reading as a string of characters, and we know the part number is embedded inside of that string, we can use an instruction to extract that portion of the string and use it for that particular purpose. One popular instruction to do this is mid. This is a function block that allows you to extract a series of characters from the middle of a source string. This UDFB has 4 inputs. These are enable, as it only operates on the leading edge of enable, a source string called input array, a length input variable, which specifies how many characters we will extract from the source string, and a position variable that specifies where within the source string is the first character we will extract. This UDFB also has 2 outputs. There is an error output in case we specify a string that is too long, and there is an output array that will need to be inside of a loop so that we can extract each character as part of the loop. Next, we will look at the UDFB left, which allows us to extract characters from the beginning of a string. Similar to the mid UDFB, the left UDFB has an enable input, an input array input, and a length for how many characters we're going to extract. This time, we don't have to specify the starting character, as this function is always starting at the left. Similarly, we also have a UDFB called right, which we can use to extract characters from the far right or end of a string. These characters will still be returned in the proper order in our output. However, when we specify a length in terms of the number of characters to extract, we will extract that number of characters from the end of the string instead of from the beginning. Now we will look at how we can use these UDFBs in our logic in Cscape. Our logic program is based on structured text. With IEC and Cscape, you have the ability to specify different languages for different sections of code. So we have created a main loop module called stdemos for structured text demos, which we will use to call our function blocks and demonstrate the different string handling functions. Once again, the UDFBs we will be using in today's demonstrations can be accessed by contacting our tech support. To use these UDFBs that are not a part of the native instruction set, we need to import them into our program. To import these UDFBs, you select Logic Modules from the Project Navigator, then right-click and select Import Logic Modules. From there, you can navigate to the UDFB files you have downloaded and select the function blocks you want to use for your project. Once these files have been imported, they will appear under UDFB modules. First, we will look at our left, mid, and right UDFBs. Once again, when we are utilizing UDFBs in our logic, we don't call the UDFB directly. Instead, we call an instance of the UDFB. We have created these instances in the program variable window. Here we have named these mid FB, left FB, and right FB. We have also set variable types for these instances to mid, left, and right respectively. Now let's look at the syntax for this function. Once again, midFB is the instance of our mid function block. This has 4 input variables. These are enable, an input array variable without any square brackets, a length variable for the number of characters we will extract, and the position in the string that we will extract from. We also have an assignment statement to retrieve the error flag and find any errors. So we have the variable we have created for this demonstration, the function call for the instance of the function block, and the output name, which is ERR. When we are using assignment statements, we always need to use a semicolon at the end. Here we have our last assignment statement. The output of this is an array, which is part of a loop. We have assigned an output array variable here, and we have an output called out_array. Then we have our index inside of our square brackets, because as we go through our loop, we need to execute our assignment statement once for each character we're retrieving as an output. In this example, we would go through the loop 32 times. We use similar syntax for our left and right functions. Now let's look at our bench setup for this demonstration. In the middle of our OCS screen, we can see the current value of our input array is A, B, C, D, E, F. Once we execute the mid function, the output array will be shown in the space underneath this. We can also specify how many characters we want to extract from our input string and at what position we will start at. These are currently set at 3 and 1 respectively. Now we will execute the mid push button, which will turn on the enable bit. We are retrieving 3 characters starting at position 1, so we get an output of ABC. If we change the position to 3, we will now get an output of CDE because we are starting at position 3. We will note that even though arrays are usually 0-based, these positions are 1-based. So in this example, the third position in this string is C. Next, we will look at the left and right functions. Let's first look at the left function. Once again, we will extract 3 characters from our string. We don't need to specify a position here, as the left function starts at the left or beginning of a string. When we execute our left function, we once again get an output of ABC. Now let's look at the right function. Here we will extract 5 characters from the string starting at the right or end of the string. This gives us an output of B, C, D, E, F. Next, we will look at the concat UDFB. This UDFB is used to concatenate or join together 2 strings. This UDFB adds strings together as one longer string and stores it in an output variable. This UDFB also tells you the length of the string it has created as part of its output. So if we concatenated a 5-character string and a 6-character string, we will get an output length of 11. This can be useful for building outgoing string data. Now we will look at this UDFB in Cscape. Here we have the syntax for the concatenate function. As before, we created an instance of this UDFB in our variable listing after we imported the UDFB files into our project. This function has 3 inputs. These are enable, as well as 2 input arrays. We also have 3 outputs. We have an error output and a length output, both using assignment statements, as well as an output array, which is inside of a loop, so our output assignment is executed once for each character that we will retrieve. Now let's look at our bench setup. Here we have 2 strings to demonstrate our concatenate function. These are in1 and in2. When we execute our concatenate function, we can see that we have created a new output string, which is the 2 strings joined together. We can also see on the bottom of our screen that our new string is 9 characters long. Finally, we will look at the find character UDFB. We would use this to find a character within a string, such as a specific character in a barcode. The find character UDFB we have created has 4 inputs. These are enable, an input array, the last position we want to check, and the character we want to look for. We have a variable for the last position to avoid overrunning the string array as we search for the character, in case the character we are looking for is not in the string. This could cause a loop problem in our function, so we have this last position input variable as part of this UDFB as a safeguard to make sure that if the character we're looking for isn't in the string, we will get returned a -1 as the position and avoid causing an exception error. For example, if we have a string that is 32 characters long, we would set the last position to a value of 32 to ensure that the function would never check beyond the 32nd location. Now we will return to Cscape and look at this find character function. Once again, we start by importing the UDFB files into our project and creating an instance of the function block. Here we have our function call as well as 4 inputs. For this function, we have a Boolean variable for the error and the character position as a double integer for the outputs. We do not need an assignment statement within a loop for this function. Let's test this function in our bench setup. We will be using the same input string that we have been using for the previous demonstrations. We have set the last position as 32, so we won't search past the 32nd character in the string. We will look for the character f in the string. Because these positions are 1-based, we are returned a value of 6 when we execute our function, so the character f was found in the 6th position. Finally, we will look for the character z. Because this is not in our string, we are returned a value of -1. That concludes our webinar for today. Thank you so much for listening, and the Q&A session will begin shortly.
Okay, I'm not seeing anything in that just now. So next week we do have find operations using structured text. So that'll be the same time and same day next week. Okay, just I thank you for the webinar, not a problem. As usual, all these webinars will be put up on YouTube and available from the website, which you can see down here in past webinars. And if there's any further ones you would like us to create one on, just let us know and we can put it in the list. Okay, thank you all very much for coming, and we hope to see you next week.